What's up, Friday students? It's asynchronous day. Hooray! That's exciting. That means we don't have to take a quiz, right? No, you still have to take the quiz. You're going to take it during the class period. I'll pop it in to make sure you're doing what you should be doing. So you're watching this video at the beginning of the class period. You're going to do this independently. Then you're going to close this video and you're going to take the quiz. I'm going to make sure you're doing that. I'll pop in. You gotta make sure you watch this video because I am doing problems a little bit differently on your quiz than maybe on your homeworks because there are less numbers. What does less numbers mean? That means like instead of asking you about functions like x squared plus 6x plus 8 and asking you to like find the continuity and examine the continuity of something like this. And then in the bottom, it's going to be x squared minus 16. And then you like factor the top and the bottom. You're only going to have to factor like one thing on this quiz. The rest of the stuff is going to be already in factored form, which makes it a little bit easier. We'll talk about what that looks like. Okay. But because things are going to be in factored form, to make it a little bit harder, I'm not going to use numbers. There's going to be letters. That way you can't just type it into a graphing calculator or to Desmos or just like plug it into like a program and be able to look at stuff. Okay. You're going to have to understand the concepts. Okay. So factoring something like this, not as important for this quiz, but for future like quizzes and tests, they'll show up. Okay. So a lot of your questions will be the following. Find the discontinuities of the function, label the type of continuity of discontinuity is what it's supposed to say. If it's removable, find the location of the removable discontinuity. Okay, so just like you were asked to do on your homework. So the first thing is told you that A doesn't equal B and that doesn't equal C. And like, here's your function. Okay, let's examine the continuity of the function. Well, we know that things are discontinuous if we have a function, just an expression of x's. And first, know that x is your variable, a, b, and c are numbers, okay? They're not equal to each other, but they are numbers. I will tell you that most of them are going to be like positive integers. You can think of them as a positive integer and you'll be safe, okay? You know for continuity that the first thing you do is set the denominator equal to 0, right? And sometimes you have to factor to be able to solve and set the denominator equal to 0. Well, in this case, if I have x minus a and x minus c equal to 0, now this might seem confusing, but don't let it confuse you. Think of a and c as numbers. Well, if x was a, then a minus a is 0, right? Doesn't that make sense? And if x was c, c minus c is 0. You could almost, potentially plug in values here, as long as the values are different, 4, 5, and 6. You'd be like, oh, 4, 6. 4 minus 4 is 0. 6 minus 6 is 0. Okay? And then we got to discover, are things removable, not removable? Infinite or not? Well, infinite, or is there a hole and we could find the location? Well, the first thing I could do is that these x minus a's can cancel because I have multiplication. So really my simplified function, I could call it g of x. I could call it like, my second simplified function f of x. I forgot what I called them in the homework video. I got x minus b over x minus c. Okay. Now, if this is my function, could I plug in c? No, I can't plug in c. If I plugged in c, I would think about c minus b being some number, and I have a number over 0. If you have a number over 0, you know that that's a non-removable discontinuity. It's an infinite discontinuity. Okay? Infinite just means a vertical asymptote. Number over 0, vertical asymptote. Then you're asking yourself, and that's if I plug in C, could I plug in A? Yeah, I could plug in A. If I plug in A, I get A minus B over A minus C. Whatever that number is, that would be the location of what is a removable discontinuity. Now, a lot of people, so I would say this is removable, and the location is at a comma a minus b over a minus c. Okay, like if you use numbers, I know you'd feel more comfortable with that, but this shouldn't be that bad. Now, where people make mistakes, and pay attention if you didn't do the lesson at all, is they, before they set things equal to 0, they cancel first. A lot of people think, oh, look at this function. Oh, I can cross this stuff off. And they cross stuff off immediately. But after they cross stuff off immediately, they remove the fact that there is a discontinuity at A. Okay, you can't plug in A into this function as you see it. If I plugged in A, I'd get 0 over 0, right? We know that if you get 0 over 0, that is an indication, write that. That is an indication that we have a removable whole. Okay, if you get a number over 0, which happens when we plug in C, after simplified, we get a number divided by 0. Actually, you can plug in C from the get-go, and you get a number divided by 0. Okay, so a lot of your questions on your quiz will be like this. Okay, examine the continuity. Okay, x equals a is a discontinuity. It's removable. The location, after simplifying, you plug in, you get the location. Then x equals c. I can't remove the inability to plug in c and get 0 in the denominator. Or you could say, okay, since I get a number over 0, c. Don't cancel until you've identified your discontinuities. Let's look at another one. This is the only thing you're going to have to factor, something like this, x squared minus b squared. If you think about it, that's similar to like x squared minus 16. That's x plus 4, x minus 4. That's x squared minus 4 squared if you wanted to do that. And then you'd say, okay, x squared minus 4 squared, that's x plus 4, x minus 4. You will see on your quiz, I won't have numbers, but I will have x squared minus like another value squared. B is a number. Okay, think of it as a positive integer. So you need to be comfortable with factoring something like this. You get x plus b, x minus b. Okay, it just came from like this, and that's fine. And then you need to be comfortable finding the discontinuities of this. Well, immediately I see if I set the denominator equals 0, don't cancel things first. Okay, here's my function. What can't I plug into this function? Well, I can't plug in negative b or b. So that's like 4 or negative 4, right? Because if I plugged in negative b here, negative b plus b is 0. If I plug in b here, b minus b is 0. So I know like this might be weird with a's and b's, but it should make sense to you. It's just use numbers. If you're ever confused, you can just use numbers and you'd be able to figure it out. You can make that 4 or negative 4. Anyways, let's keep going. So these are discontinuities. Well, I realized that no matter what, I will never be able to plug in negative b. I will get a number divided by 0. Okay, so also you can see that when you cancel things, you end up with 1 over x plus b as you know, your secondary simplified function. And we can see that I can't plug in negative b. I get a number over 0. So negative b is our non-removable infinite. Okay, and then what about b? Well, I can plug b into this. If I take this simplified function and plug in b, I get 1 over b plus b. What's b plus b? It's 2 b's. So this is removable, and its location would be b comma 1 over 2b. I know you're more comfortable with numbers. If you wanted to, you can use numbers to double check things. Like if I had x minus 4 and x squared minus 16, you'd find that the whole's location would be at 4 comma 1/8. So this might throw some people for a loop, but you need to be ready for it. This is me getting you ready for it. Pointwise functions, remember these guys? This is just huge. So this is the situation where you have like a function for every single point, except for like at 2 locations, maybe here, And at those locations, you're leaving that function. And what you're doing is you're hoping that the other points provided fill in the gaps so that things are continuous. Now, there are situations where, like, well, maybe my original function that's being used everywhere ends up having an asymptote, maybe like right here, a vertical asymptote. And if that's the case, well, then like no point, no matter where it's placed, will fill in the hole and make things continuous. So if there's ever a vertical asymptote situation like that, you can't be continuous, okay? And for this guy, we are using x minus c over x minus c times x minus d for everywhere except for at c and d, okay? Again, this is already like kind of simplified for you. All right, well, let's just examine this piece because I'm going to be using this piece pretty much everywhere. Let's just assume that's our function, okay? And let's examine the continuity. Well, let's take the denominator and set it equal to 0. When can't we plug in 0? What values can we not plug into this function? And immediately you say, okay, well, c will make this 0 and d will make this 0. Okay, so those are discontinuities. Well, look at that. C and d, I'm not using. I'm using this for c, and I'm using the same point for d, the c minus d. All right. Well, now I'm going to go ahead and say, like, well, let's try to simplify this guy. Let's just look at this top piece and let's try to simplify it. Well, so it starts out as x minus c over x minus c times x minus d. And I notice, oh yeah, these x minus c's, they can cancel. And since they cancel, my simplified guy is 1 over x minus d. I still can't plug in d into this. Okay, if I plug in d, I get 1 over 0. Number divided by 0 means we have a vertical asymptote. We have an infinite discontinuity. So at d, for this piece, I know I have an asymptote, non-removable discontinuity. So like, let's pretend we have d here. Well, this piece will be going towards an asymptote, which means this c minus d, wherever that may be, I don't know where it is, but you can use numbers and like, I don't know, mess around with it. C minus d, no matter where it is, would not fill in any gaps. It would not make the function continuous. So immediately I know x equals d is bad. It's a discontinuity. It's non-removable. It's infinite. I tried to remove it with this point, c minus d, didn't get removed, okay? But, oh, I messed up. Let's pretend this is 1 over c minus d. And this is c minus d. Sure, that's good. All right. Now, let's go and say, okay, looking back at this piece, where's the location of a hole? And I notice that d is bad, but c I can plug into my simplified version. And if I've plugged in c into my simplified version, I see I get 1 over c minus d. What does that mean? That means this big function, which is used everywhere, wherever we got c, let's say c is here. At c, we have a hole on this big piece, okay? Well, it turns out that, and then it's got an asymptote wherever d is. So let's say d is over here. There's my asymptote at d. Well, it turns out this point, c, comma, 1 over c minus d, fills in that location because we have a hole for this guy at c, comma, 1 over c minus d. But this entire function says, well, I'm giving you a point at c, comma, 1 over c minus d. Well, that means since this location of this hole is filled in by this point, the function is continuous at that location. So I'm going to just make sure you know and state that, okay, this is a discontinuity at d. This still isn't going to help me at d, but at c, x equals c, that's a removable discontinuity. and it was filled in. So it's not a removable discontinuity, it's just continuous. So it was a removable discontinuity filled in by the point. So I'm going to say that x equals c is continuous because c comma 1 over c minus d, which is this point right here, fills in the hole from x minus c over x minus c, that's x minus d, at x equals c. If you didn't do these problems, these pointwise problems on your homework, if you didn't watch the video about the pointwise problems, this makes no sense. If you did, then you should be like, okay, I guess it's a little bit more complicated with these letters, but I'm going to be fine. All right, let's keep going. Find A and B. This is another way, and this is no different than kind of what you've seen. So we're going to practice this really quick. Find A and B to make the function continuous. So here's this is a situation where we're going to finally have some jumps. Now we should remember the other jump function, the only jump function, ends up being this absolute value of x over x. We know that that's like from x to the right, it's approaching 1. X from the left, it's approaching -1. We're familiar with that. That's a jump function. That's a jump function. It's the only kind of expression where you're going to have jumps, is using these absolute values. The other things that have jumps are the piecewise functions. So here's my piecewise functions. Now, to ensure things are continuous, we got to have the pieces meet up with each other. Well, that means this piece and this piece need to meet up at -2. This piece and this piece need to meet up at 3. All right, so I'm going to split this, and this is what I do for these problems, is split this into like 3 different pieces and say, okay, f little 1 at -2, that's got to equal f little 2 at -2. I'll plug in -2 for x for both of them. I get -4 plus 1, that's -3. I get -2a plus b. Nothing I can do. Okay, so we need another equation. Well, f little 2 at 3 needs to equal f little 3 at 3. All right, so f little 2 at 3, that's going to be 3a plus b. F little 3 at 3. Okay, this is tricky. -x squared. It is not -x squared. It is -x squared. If you're doing order of operations, you're going to take your number, square it first, and then make it negative. So this is a little like heads up, because you're going to see this in the future. Don't make mistakes on this. -x squared means take your number, square it, and then make it negative. So it'll always be a negative. This is a -9 plus 1. And that simplifies to be 3a plus b equals -8. Okay, what do I do now? I got 2 equations, 2 unknowns. I like to use substitution. It is easy. I can just solve maybe one of these. I'm going to solve this one for b. Why this one? I don't care. You can solve this one for b. Subtract 3a to do that, or add -3a. Move that in for b. So I get 3 equals -2a plus -8 plus -3a. Make sure you're paying attention to if you need to distribute things, which we've done in the past. Going to combine like terms, same side combine. So -2a, -3a is -5a plus -8. I'm going to solve for a. Okay, so I'm going to add 8 to both sides. -3 plus 8 is +5. I'm going to divide by -5, and I get a is -1. Fantastic. Once we know a, substitute it into either of the equations that you have a's and b's in, and you'll find b. This is an easy one because it's already solved for b. B is equal to -8 plus -3 times -1. That's +3. -8 plus +3 is -5. So b equals -5. Now, what you will see on your quiz to make it even more difficult for you guys to cheat on is not find A and B, but literally find A plus B, which means you take A and you add it to B, and you say, and your answer is going to be -6. Right? Doesn't that make things trickier? You can't just like plug in the values of all of the 4 answer choices and see which one works. You're going to have to find them yourselves, and then take the 2 values you find, add them together, and your answer to this question is -6. Isn't that cool? Aren't you glad that I'm not there today to help you with this stuff? This is kind of sink or swim situation. Here's another pointwise. Prepare you for this one. Again, like if you don't understand pointwise, like it's because you didn't pay attention to that portion of the lesson and that portion of the homework. We're using this guy everywhere except for at 2. And then for at 2, I'm using B. I need to find B. All right, well, let's just like examine this guy intently. All right, well, that guy has a discontinuity at 2. That equals 0 at 2. So x equals 2 is a discontinuity for that. But if I plug in 2, I see it's 0 over 0. So I know it's actually removable. Well, let's find the location of that removable. We need B to fill in that location. And if B fills in that location, the function is continuous everywhere. We'll have a situation where we have, a hole for this guy, but then this point B fills in said hole. Boom, we're continuous. Tricky stuff, but this is what AP Calculus students do. Okay, so let's examine this little guy. X squared minus 4 over x minus 2. Well, we realize, and you guys know because you've practiced this, that x squared minus 4 can be factored to be x minus 2, x plus 2, or vice versa. And you realize that, you could cancel that guy. Maybe we create, f little 1b. And turns out this function is really the same as x plus 2, only this piece has a hole at 2. This does not. This will enable us to find the location of said hole. Well, f little 1 at 2, that gives me 4. This piece here, with all of this work done, tells me I have a removable discontinuity at x equals 2. The location is 2, 4. So if I were to graph this function would look like a straight line, but this guy would have a hole at 2, 4. Well, I want B to fill in that hole. Well, B's got to be 4 for that to work. Now, I can make things different and make it like B plus X or something like that. Well, make sure we're paying attention to things like that. B is not going to be 4 anymore. B plus X needs to equal 4 when X is 2. So B plus 2 equals 4. B's got to equal 2. So pay attention to other stuff being added in to that point and make sure you're plugging in X into that stuff. Okay? Do we understand the intermediate value theorem? You all have one question on the intermediate value theorem, and I hope you do understand it. Here's how I'm going to make sure you understand it. I said what y values must exist for some x on the interval from 1 to 3 for this function. And here's a crazy cubic function where it's very, very hard to solve cubics by hand. You gotta hope that you can factor, but in most cases you can't. So you use a calculator to solve cubics by hand. So anyways, what solutions, can I set this equation equal to 0? And will I have a solution between 1 and 3? What can I set this equal to? And I know I have solutions for. Well, first of all, you notice that the function is continuous and it's continuous everywhere. So that's good. That means the intermediate value theorem applies because the function is continuous. All you need to know is 2 points. The point at 1 and the point at 3. And then we'll graph. And then we'll kind of fill in the gaps. So plug in 1, I got 1 minus 5 minus 4. So 1 minus 5 is negative, 4 minus 4 is negative. I plug in 3, I got 27 minus 15, which is 12. 12 minus 4 is 8. Okay, so this cubic function has the point 1, -8, and it's got the point 3, 8. What do you know? No matter how you connect these 2 points, you are guaranteed to have every single y coordinate for some x coordinate between 1 and 3. Those y coordinates must be between -8 and 8. I will have some x between 1 and 3 such that f of x equals all the y's between -8 and 8. So that means there is some solution to x cubed minus 5x minus 4. The solution is going to be between 1 and 3. Now, could you solve this? No, you can't solve this by hand. You could solve this using a calculator, though. You could solve this using some other technique. But you can't solve that by hand. But what the intermediate value theorem does is say, I don't know what it is, but I know where it is, and I know that it exists. I know it exists. I know where it is. I know x is going to be somewhere between 1 and 3. I mean, I could actually solve this equation. Let's see if Siri can solve this equation. Whatever. You can. I can show you with a calculator how to solve it, but I don't really care. Somewhere between -8 and 8, 0 happens, which means there is some x between 1 and 3 to produce that y of 0. Okay. So what y values must exist for some x on the interval from 1 to 3? All the y values from -8 to 8. It's our quiz. Continuity is kind of tricky. And I made it a little bit trickier because I used letters so that you can't cheat. But that is the life of remote learners. Do the quiz. Are you ready for asymptotes? Asymptotes are tricky too. So you got to study that. Let's talk about your check-in that you're going to do and then the quiz. And let's talk about what things look like moving forward. So here's your check-in. You're going to make sure you do your check-in. Your check-in states, I understand my responsibilities for today. I watched the practice problems video to help me prepare. Hopefully you already did this check-in. If not, whatever. Then I'll do the quiz during class time. I have one more lesson of material in Unit 1 to learn and master over asymptotes. This is a long lesson, so I'm prepared to put in the work and practice. Next class is the review day, which will include practicing, then taking our final Unit 1 quiz. We'll discuss how to prepare for the test. You're going to be doing the test at home, like we're doing now, but it's not going to be an average of quizzes. It'll be an actual test during class. We'll just get started right away when we start class. All the previous quizzes answers will be released on that day. So if you have a missing quiz for me, it needs to be done before or on the review day, because I will be releasing every single quiz and their answer keys on that to help you study. Okay, your test, your Unit 1 test will be multiple choice. It'll be all online, so normal. But you're doing it during the class period, so you can't cheat much. If you have not taken all your quizzes by the time the review day rolls around, the end of the review day, because you can take quizzes during the review day, you're going to get a 0. If you have any questions, you're going to email me, fill in this check-in, and then you see the asymptotes homework, the asymptotes homework key. I will type into this that this is our day 3 lesson. This is the day 3 homework video, and you will be able to start your quiz at 10:18, but probably you're going to start a little bit later. Here's the quiz on continuity. Okay, so good luck out there, and I'll see you guys on Wednesday after the 3-day weekend. I have to press stop somehow. There you go, stop.